Okay, so yeah, so I'm gonna be talking about SwiftUI performance tips. Tim already introduced me, so I will not go into much details here. So I'm leading the iOS team at Stream that produces SDKs for chat, then activity feeds, and also we are launching a video calling SDK soon. And you can also find me on my blog or on Twitter. So a lot of our work at Stream deals with performance because we are basically displaying like endless lists of data with different types of media like images, GIFs, videos, custom attachments, and so on. And in this talk, I will share about what we've learned from building our SwiftUI SDK, as well as some other apps that I've been involved with. So first, let's define slow. So what are some things that you think about first when you think about slow? So we have the sloth, which is, according to Google, the slowest animal on Earth. We have the snail, and we also have some browsers that are famously slow. And however, in terms of mobile apps, we are mostly talking about slow. We think about dropped frames. And here I would like to do an analogy where I'm delivering a presentation. So imagine I'm delivering a presentation. Oh, wait, I'm already are. So we have here like slides. I have some allocated slot of, let's say, 30 minutes, and I split this time in slots. And each slide has like definite number of time where I should speak it. If I overdo it, then I would be late, and the next slide would be delayed. And as a consequence, either I will have to cut something from the next slide in order to finish on time, or even more, I will have to cut your well-deserved break. So in these cases, there is a delay, and you, as a consumers of the content, are losing something. So either your time or a content that was lost. And the same is with mobile apps. So if you don't finish the job on time in one frame, then there would be a glitch. So the frame would appear longer than expected, and this will trigger some bad experience for your customers. And if we go like more specific in iOS performance metrics, so previously it was mostly like frames per second that was used as a measure, but now lately Apple recommends that we use animation hitches. And basically a hitch is when a frame appears on the screen later than expected. And the hitch time is basically the delay that happens. And the most comparable metric that Apple wants us to use is the hitch ratio, which is basically the ratio of hitches in milliseconds over 1 second compared to some other time interval. So yeah, that's about the theory. And now let's see what we can do in our SwiftUI code to introduce these hitches and how we can fix them. So this is not like a definite group of issues that can appear, but things that I find common on the types of apps that I'm working on. So we have things like doing something heavy on the main thread, then frequent redraws, using wrong SwiftUI components, off-screen rendering, and large media data. So we'll cover all of those in this presentation. So the first one is kind of obvious in any UI development, so not only iOS or SwiftUI. So if you do some kind of a long-running operation on the main thread, then the main thread won't be available to respond to user actions or to other events, and basically your app will look unresponsive. And while this is like very common for all SDKs, in SwiftUI I've noticed that you can easily do mistakes like this with computed variables. So as you know, SwiftUI evaluates the body of a view many times. And you need to be careful when you use computed variables not to do some long-running operations. So they need to return like really fast. And this is like a real-world example from a customers of ours where they reported like slower performance on our chat message list when they use their own custom attachments. So at the bottom there you see this rather like innocent method has attachment that just checks if you have an attachment and basically show this in the UI. So this is like reference from the SwiftUI code, and all looks fine. But if you, for example, check how the attachment is loaded, you will see that it's also a computed variable. And it always loads the contents of the attachment, then it tries to decode it, and this is called like many times on each redraw. So you can imagine how slow it is and how wasteful work is done here. So that's why you should be considerate of computed variables and not put like some very long operations in those. And you can solve this like in a much better way. So you can introduce like state where you only check this once, or even rework the logic where you check if you have an attachment, if you have something on that particular URL. Then another interesting thing that I've noticed in apps where the main thread can be busy is core data and other similar database solutions where, as you might probably know, core data is expected to run on a single thread. And if you want to display like managed objects directly in the view layer, which is not something that's actually recommended, but if you do, you will need to load them from the view context, so basically the main thread. And when you start doing like stat screen where you need to combine multiple types of data, and when your data grows, you will hit performance issues. And here, I would say the best way is to always load them on the background thread and then map them to like a simple struct that would be passed to the view layer. Or if you really want to use like NS managed object, you can use object ID to pass it from one thread to another. And another thing that really speeds up apps is caching when you have like networking or database access. So caching of images, or in the case of a chat application. So for example, you have a message list where you have thousands of messages, but the authors are usually 10, 20, or even 100. It's not really important, but you can cache those and avoid some unnecessary trips to the database. And this will also improve performance a lot. So another group of performance issues in SwiftUI can appear when you do frequent redraws. So as you know, SwiftUI evaluates the body of a view a lot of times, but if you make some mistakes in your code, you can make it do it like more than it should. And if you have very frequent redraws, your performance will suffer. So here on the slide is another example that I have actually written, and it's you have like a view model, and it stores some elements and some images, and you have a method that returns immediately an image. So if you have it in the cache, it returns it. If not, it tries to load it, but immediately returns a placeholder. And here on the other chunk of code, we have how we use it in the list view. And we pass this method in the list item itself. And when you run this, the first time while the images are loaded, you will see a lot of dropped frames. And this is a typical example of badly structured code where you put a lot more state to the list item than it should. So whenever images are changed, all of the list items are redrawn. So the state is not localized to a particular view, and basically it redraws all of the list items. So you can imagine that's a lot of redraws on every image download. And how you can fix this? So one option, of course, is to do it properly, where you have one list item that depends on one image, and it's redrawn only once when the image is downloaded. But in some cases, for example, if you are building an SDK and you've already shipped this method and you can't really change it because it's a breaking change, you could do something like batching updates. So you can, for example, like here in this code, you can remove the add published property wrapper and basically use the wheel set to schedule updates. So for example, you can publish with object will change.send and do this like every interval, like half a second, 1 second, and so on. And this will have the effect that all the images will appear at once, while the performance will not suffer because you will basically avoid those unnecessary redraws. Then when we are talking about unnecessary data updates, another example here also, this is, for example, when you implement something like gesture-driven, so you have, you move something with your finger and you want to change the offset of the view. And you have some other state when some threshold is passed, you want to update, I don't know, swiped message ID. And in the first code, we are always updating the state. And if that state is kept in some view that is higher than this view, it can cause also unnecessary redraws. And you will see, like when you swipe, some dropped frames. And here, the fix could be quite simple. So in the other part of the code, you can see that we check if the value is changed and basically spare some unnecessary redraws. Then another type of performance issues can appear by using wrong SwiftUI components. And one example of this is the usage of AnyView. So we've seen the slowest animal on Earth on the first slide, and now we have it here. So because it's quite slow, the slot usually camouflages in the environment and basically tries to look like it. So it's harder to spot in the forest, and basically that's how it protects itself from the dangers of the forest. And basically with AnyView, you are doing it the same way. So you are hiding from the rendering framework who you are. And this can be a problem for SwiftUI. So if SwiftUI doesn't know who you are, it's harder for it to compute the diffing, because SwiftUI relies on the types of the views, so basically the identities of the views, in order to compute the different state transitions. And if it doesn't know who you are, then it will just assume that it always needs to redraw the view. So that's why also Apple recommends you should try to avoid using AnyView, especially in cases like where you have this use case like large pieces of data where you scroll and so on. And especially if that list is reactive. So if you have like reactions popping up every second and so on, if you use AnyView, this would be quite an expensive operation. And basically you should avoid it. And of course the best way here is to use generics. And if you compare this to the code with AnyView, is quite simpler and very tempting to do, and actually quite scalable. So if you want to provide some kind of a container view where you can inject views from the outside, if you want to add 10 injected views, you can easily add them and they're all marked with AnyView. But if you go with the generics direction, you will need to provide all the generic types, which could be a bit of a problem. But still, you could do it like create some protocol, like on like here with the view factory on the right, and you can define like associated types and create like injection slots, and everyone can. So for example, you can provide default implementations so customers don't know and the generic type is already resolved. And then in the example view that uses this, so basically the container, you would be generic only over the factory. And this is also quite scalable and has basically similar usage to using this other non-performant AnyView solution. Then, while we are talking about view containers, sometimes you can basically make the mistake of using lazy or non-lazy in the wrong place. So, as we know, we have like a lazy VStack, lazy HStack, but also their non-lazy counterparts. And here, for example, if you are building some kind of, I don't know, a recipe app, and you want to if you use like a VStack in a scroll view, then all the items will be rendered at once, and this would be quite slow. So in situations like this, much better alternative is to use like lazy VStack, which will basically load all the items when they appear. So it will try to render them when they appear. And here, another extreme that could go wrong is, of course, if you think like, okay, lazy is always better, and put everything lazy. So in those cases, SwiftUI might even have a rough time figuring out everything on demand, and it can not only introduce performance issues, but even mess up the rendering. So you can try things like putting everything lazy and see what happens. Then another component is the geometry reader, through which you can basically read the available size of the view that's proposed to the view that's using this component. And in the early days of SwiftUI, people were using it to basically, I don't know, if they wanted to control the size of the view. In those cases, I would say it's not really necessary. So you can use spacers or frame modifiers for this job. For some things like getting like the scrolling position in a message list or anything else where you need to know the scrolling, then it's quite useful. So we are using it, and we haven't seen like performance issues, but it's more like use it only when you need it. And you should be aware of the new layout protocol in SwiftUI, that some of the things that we've done with SwiftUI with geometry reader are now not really necessary, and you can do them with the layout protocol. Then we have off-screen rendering as a performance issue, and this happens when the GPU draws something in a temporary place. However, I will not talk about this in much details, because Pranya, after me, will have a talk about how to draw better shadows, and she will explain this in more details for the off-screen rendering part. Then we have, so no matter how hard your app is efficient, like code-wise, if you have like very big images, videos, and so on, then you will for sure have performance issues. And if you have like, I don't know, 20 megabyte image, and you want to show it like in an avatar that's 40 by 40 pixels, and you do it like for, I don't know, 10, 20 users, then of course your app would be very slow. And how you approach this? So you could do something like, the best way to solve this would be to load thumbnails from a CDN, where you basically send to the backend the width and height of how much do you plan to allocate for this image, and the backend will return you the correct image. And this is also the best way memory-wise, because you don't load images that are big in memory. However, not everyone can have or afford a CDN. So in those cases, what you can do is basically load the big image, then resize it locally on some background thread, and then when you have it like in a smaller size, send it to the view layer to be rendered. So this also improves performance a lot. So in the first versions of our chat, for example, we didn't have the CDN up and running, so we did it like this, and it works well. And you can use, for example, Nuke for this. Then we have, so how do we spot these performance issues? So I think the best way is by using instruments. So it's quite a useful app that's been here for a while, and it basically gives you everything that happens in your iOS app. So for example, me personally, I use 3 profiles the most when I debug SwiftUI performance issues. So for example, the time profiler here gives you like the percentage of where your time in the app is mostly spent. Then another quite useful is the animation hitches one, where you can see like frame by frame everything that happens. And for that, Adam tomorrow will present some more details about the animation hitches profile. And also another one is the SwiftUI profile, which with that one, for example, you can count how many times the views are redrawn. So if it's too many times, like you expect something around 2 or 3 and you see like 10, then you know that something is really not good and that you need to take some actions to basically fix this. So yeah, you should try to use instruments because not only they will help you fix performance issues, but you will understand more about the render loop and everything, how it works. And it can be overwhelming at the beginning because you see all this stuff. So one thing that you can do to get started is basically to introduce like a performance issue on purpose and try to find it via instruments. Then we have performance testing. How do we make sure that things are running over time, like in a good manner, where we don't have regressions? So not sure if anyone here has read the book Creative Selection from the former Apple engineer Ken Kosienda, where he talks about the development of several Apple products like the iPhone and the Safari browser. And there is an interesting story there about the development of the Safari browser, where they had like a requirement to have the fastest browser on earth. And how did they approach this? So basically they've created like a page load test with a benchmark, and you can only merge new code into the main branch either if you keep the same performance level or you make it faster. So if you make the code slower, it would be like you won't be able to merge it unless you fix those performance issues. So basically that's like an early 20 years ago way of doing PRs and PR checks and all that stuff. And nowadays you can do this with exit tests. So the tooling has improved a lot. And basically you can follow this rule, like become faster by never getting slower. And you can do this with, for example, the signpost metric called scroll deceleration metric. And here we have one test that we use for our SDK, where you can do like on the same set of data, you can do like performance tests. So you run it, you swipe up, and then you stop measuring, and then you swipe down, and you see if you broke the benchmark. So if you made the code slower, it's actually easy because you can hook this in a CI check before merging the code. And when you have the performance issue, it's very easy because you can localize it to that particular PR. So it's really nice if you want to avoid some kind of a performance regression. So in a nutshell, these are the things that we've discussed. So basically, you should be careful when you use the main thread. You should be aware of how SwiftUI works, the rendering mechanism, and how the components work and what they offer. Try to not use big media files because they influence performance a lot. Instruments are there to help you, so use this quite a lot when you have performance issues. And of course, do performance testing to avoid regressions. So thank you all for your attention. Hope you will have a nice conference, and your apps will be as fast as these 3 things here. So yeah, thank you.